Okay, so we have an example here, just a preamble to the example. It said that the Southern Textile Company has decided to install a new computerized system, and I know that the company wants to know how long it will take to install the new system. So this is information on the activities involved in installing the process, and we have a certain number of activities, so activities A to K, and then the descriptions are given there. Now here we see the predecessors, or the order in which the activities are supposed to occur. And then we have the A, M, and B here, our optimistic, most likely, and then the pessimistic time estimates there. Now in all instances, you do notice that our pessimistic time, or the pessimistic times, are higher than the optimistic times. Okay, so that's something for you to note. And then the most likely times are kind of found in between the optimistic and then the pessimistic time. So very easy. The only thing here we need to do is to compute our expected time for each activity. And so the heading, as the heading states for the durations, you have A, M, and B. All you need to do is, for activity A, you just need to do 6. So it says it is A plus 4M plus B all over 6. Okay, so all you're just going to do is you do 6 plus 4 times 8 plus 10, all divided by 6, and that will give you your expected time for activity A. You do the same for activity B, and you go in that order. Okay, so let's take some time and just compute the expected time for each activity, and then we'll get back. I'm not going to go through drawing the network diagram and getting the critical path. If you want to get this one, just do a little recap and go over the previous recording, the previous video, and then you get how we draw the diagram. And in any case, I have the solution in the slide, so you just vet it. I think that will be a good challenge for all of us. You look at it and then you compare it to what you've gotten, and you should be fine. Okay, so when I did my expected time for activities A, B, C, D to K, the first one for activity A is 8. Okay, so what I did is just to take 6 plus 4 times 8, okay, times 10, plus 10, sorry. And that gives us, divided by 6, and that gives us 8. I do the same for all the activities, and then you have this. So now it's made everything simple. Once you've gotten this one, you've eliminated that A, M, and B. In fact, that is what we've put together to get the expected times for all the activities. The next thing is to draw your project network diagram. Okay, so this is how my network diagram looks like. So you do see that activities A, B, and C are all the initial activities. So they all do not have predecessors. You see it. So activity A is the first, activity B, activity C, they're all the same. Now if you go back, activity D is preceded by A, and then activity E also preceded by B, and then activity F preceded by C, G preceded by G. It goes in that same order like we've seen. So you just follow the same thing, and then you would get it, that easy. So you do see that some of my arrows are crossing. Now, like I have said, there are instances that you cannot have, you may not have anything. It's like you can't do anything about it. But this is, I want to draw our attention to this. If you can have, or you can place your diagram or your notes in a way in which you can avoid the arrows from crossing, I entreat you that you choose that option. But if you can't do anything about it, what you can do is make sure that your diagram is well spaced, so that even if the arrows are crossing, it wouldn't be difficult to analyze them. So you do see that in my case, I left them to cross each other, but the spaces are enough so that you can see clearly from where one arrow is moving from to another point. Then you do not have any issues when doing your forward pass and then the backward pass. In doing your forward pass, the scenario is the same, just as we saw in the previous video. So just go over that video and master how to do it, and then I'm sure you should be able to get this done that easily. Okay, so we found out that the project completion time is 22 weeks. Our critical activities are B, E, I, and K. Now, if you fix in the arrows, you would have B to E to I to K. And in fact, if you want to confirm this, go back and sum the expected times of this. You notice that they will sum up to 22. So B, E, I, and K. If you come back, you see B is 6, E is 3, I is 4, and K is 9. If you add these values, you would see that they all sum up to 22. And that gives you like a confirmation to our project completion time. Now, the question asked us to, the question asked us to find the probability that the new system will be ready by 30 weeks. Now, you want to, what is the probability? Now, the reason why we want to find the probability here is that, you see, we used some time estimates, and then we took a weighted average. Whether it's weighted or the normal arithmetic average that you know, an average is an average. And so it is possible that we could miss the target, or we could hit the target, or anything. So because we say this is probabilistic, it means there is a probability that we could finish exactly as we have stipulated, or there is a probability that we may not finish it just as we planned. So we want to find the probability that we'll finish the project in 30 weeks or by the 30th week. Now, so all we want to do is we're going to compute what we call our z-score. So we're going to take this and convert it into standard form. Now, so here, okay, so forgive me, my pointer is moving way faster than I did. Now, the D. Now, I told you before that if in finding your z-score, it is normally, if we were doing quantitative methods, we will see that it is x minus mu over the standard deviation, okay? But because we are using projects, the concept is the same, but all we're just using is, we're using D. D here is just representing that duration of interest to us, which in our case is 30 weeks. Now, the E, or the ET here, is just the expected completion time, which is, in our case, is 22 weeks. So, the only different thing there, or the only thing we may have to compute, or we will have to compute again, is our standard deviation, which is sigma. You see beneath there, which is the denominator in that ratio there. So what you do here is you would first have to go back to the original question, and then we will compute the variance, but the variance will take it for only the critical activities. Now, we also said earlier that the critical path is the longest path in the network project, okay, in the network diagram. And so 22 weeks is the highest completion time for all the paths. In fact, if you list all the paths in the network diagram and you sum the duration, the highest would come from B, E, I, and K. Okay, so you take these activities and then you do B minus A over 6 all squared for each of them, and that will give you the activity. So forgive me, we are going to go back a little to the main question, the original question here. So for instance, activity B is a critical activity. So I'm going to do 9. So if I want to find the variance for activity B, its B is 9 and its A value is 3. So all I'm going to do is 9 minus 3 divided by 6 all squared. Okay, so I'll do this, and I'll do the same for activity E. And E is going to be 4 minus 2 over 6 all squared. And then I'll do for I, I'll also do 6 minus 2 all over 6 all squared. And I'll do for the last one, K, which will be 13 minus 1 all over 6. And then I square it. Now, when I do this and I sum them, it will give me my total variance. Okay, so let's go back to the slide on which we were. So you see, for activity B, its variance is 1. Activity E has a variance of 0.111. Activity activity I has a variance of 0.444. And then activity, my activity K has a variance of 4.0. Now, when I sum all these and I find the total of this will be 5.555. You get it? And so the variant, the standard deviation for the total variance there is the square root of 5.555, which is 2.357. So that is my standard deviation. So all I'm going to do is to convert this to standard form, because if I want to find the probability of this from the standard normal distribution table, I need to convert it to a standard form. That is by finding the z-score, or what we call the z-value. Okay, so to find my z-score, I'm going to have my 30, which is the let's say the sample mean. That is the week of interest to me in this question. The question asks what is the probability that we will finish the thing in 30 weeks. Okay, so in 30 weeks, 30 there becomes my sample mean. That is the number of weeks I have sampled. Okay, but the population mean, in other words, which in our case is the project completion time, is 22 weeks. And then my standard deviation, which I found as 2.357. So I'm going to get my 30 minus 22 over 2.357, and I have a z-score or z-value of 3.39. Okay, so if I have a z-score of 3.39, I'll just take my z-score and then compute this, find this from the standard normal distribution table. But you must understand that the question is asking us to take note. It says that what is the probability that we will complete our project by 30 weeks? So in other words, this is saying that we are interested in 30 weeks and below. You get it? We are not interested in anything beyond 30 weeks. So you should understand this when you are drawing the standard distribution table graph. Okay, so